Hello students, today I am taking the questions of Neet 2019 series P2. Now from question number 21 to question number 27. All these questions are theoretical questions, so their language is long. Because of that I am taking only the 7 questions. So I also told you that you watch the video completely. Whether it is long, that is no matter. But if you want to understand what is given in the question and how to apply it, and how to understand the language of the question and how to see the application, then you have to watch the video completely. You all like, share and subscribe the video. So now question number 21 to 27. Now question number 21. The radius of circle. The radius of circle. The period of revolution. Period of revolution. Initial position. Initial position and sense of revolution. Sense of revolution are indicated in the figure. Are indicated in the figure. By projection. By projection of radius vector. Radius vector. Rotating P. Rotating P is now options. Here the figure is given like this. This is X, this is Y, this is your P, T equal to 0, here T equal to 4 seconds, and particle is rotating like this. This is now center, radius is 3 meters. This is now radius 3 meters, this is also 3 meters. And options are given. First is yt equal to -3 cos 2 pi t, where y in meter, where y in meter. Second, yt equal to 4 sin pi t upon 2, where by in meter. And third option, by t equal to 3 cos pi t upon 2, where by in meter. And fourth option, by t equal to your 3 cos this is now your 3 pi. Now this is pi t upon 2, whereby in meter. The solution of this. First you see the rotation. Rotation is given to be the clockwise. And in class we study the rotation anti-clockwise. So this is just opposite what we have studied in the class. So all the measurements will be taken in the sense of clockwise. So how to do this? That this is x, this is y, this is given like this, particle is moving, here p t equal to 0 and t given to be now this 4 second. This is now origin, this is now 3 meter, radius is 3 meter. So what do we have? The particle is moving like this. It is starting from this point on this y-axis. Now let sometime this is here, and now what we have, when we study that this is now anti-clockwise, then we take the measurements from x-axis. Now the measurement will be taken from the y-axis. So let this angle is theta, and this is now suppose projection. This so much is the projection by t. This is now projection. So what do we have? Now this is to be taken. So this is suppose the point P. Then from right angle triangle OP, suppose this is the point Q. This is point Q. OPQ. OPQ. What we have? This cos theta is equal to this base OQ upon perpendicular this hypotenuse OP. So this OQ is equal to OP cos theta. And this theta is equal to omega t. So OQ, this is now your by t. This is OP to now 3 cos omega t. 3 cos omega is 2 pi upon t into t. This is now given so much. This is now your 3 cos 2 pi upon t is given to be 4 second. This is given 4 second. 4 into t. So this will cancel by 2 times. So we have this 3 cos pi t upon 2. This is your by t. So this is the answer. So we will have, if we match to this one, then we are finding that this is given to what, this fourth, by t equal to 3 cos pi t upon 2. So our right choice is fourth. So this is the answer to this question. This will, it is asked that what is the projection by projection of the radius vector. If suppose we would have asked the x projection of the radius vector, then x projection we have to draw a perpendicular on this x-axis. Then this so much distance, that will be xt, and in that case we will have this, instead of cos, that there will be the sine. So along the y-axis we are having this, and along the x-axis we will have the sine term. So this is what the difference. This is why that there is given the sense of rotation. According to that we have to select the direction. And now I take the next question. That is question number 22. A hollow metallic sphere of radius r is uniformly charged. The electric field due to sphere at a distance r from center Now option. First option, increase as r increases. Increase as r increases for r less than capital R and for R greater than capital R. Now second option, 0 as R increases, as R increases. As R increases for R greater than capital R, no, R less than capital R. Decreases as R increases, for R greater than capital R. This is now second option. and third option 0 as R increases. As R increases for R less than capital R increases as R increases for R greater than capital R. Decreases as R increases for R less than capital R and R greater than capital R. This is the given to you. First we are given the hollow metallic sphere. It means the sphere is conducting, but this is hollow. So in hollow sphere or hollow cylinder, in any kind of hollow object, there is no electric field due to the charge present on the object. So the charge, the electric field inside the sphere will be 0. So now if you have studied the electric field due to the charged sphere, then the solution comes out from its graph. This is what we have taken. This is E, here is R, then you would have known that this is, here is E proportional 1 upon R square. Here E equal to 0. This is R equal to capital R. So inside the sphere, this is 0. So 0 as R increases for R less than capital R. R less than capital R. This is not this region. Decreases as R increases for R greater than capital R. R greater than capital R means that we are going away from the sphere. This is outside the sphere. Outside the sphere, the electric field decreases with the increase of the distance. So now we have the right option is second. So our answer is second. This is R less than capital R. Here R greater than capital R. This makes the clear to find the right answer to this question. Now question number 23. In which of the following devices the eddy current effect is not used? Now first option is that we have the induction furnace. induction furnace. Second is magnetic braking of train. Magnetic braking of train. And now third option is electromagnet. And your fourth is electric heater. Electric heater. So if you know the uses of eddy currents, then you can find that in the induction furnace, eddy currents are used just to melt the conducting materials. Magnetic braking of the trains, there is also the eddy currents are used. Electromagnet, there is also the eddy currents. And the electric heater. In the electric heater, there is no eddy current, because this is depend upon the heating effect of the current. So eddy currents are not used in case of electric heater. So our right answer is what? Fourth. Now 24th question. 24th, 6 similar bulbs. Similar bulbs are connected as shown. Are connected as shown in figure with DC source. DC source and zero internal resistance. Source of EMF. Source of EMF E and zero internal resistance. Internal resistance. The ratio of power. The ratio of power consumption by bulbs when first all are glowing. All are glowing. Second, and second, in situation when two from section A 2 from section A and 1 from section B, 1 from section B will be now option. This is now your 4 by 9. Second 4:9. This is now 4:9. Second 9:4. And third 1:2. And fourth the 2:1. And now here is given that here we are having now here we will have this is A from this to this is B from this to this. All the bulbs are the similar, so they will have the same resistance. So now solution. Let R equal to resistance of each bulb. So what we have now, this is given your I can make this as this is R. So now this is A and this is B. This figure can you make like this? This is A section, this is your B section, and each bulb has a resistance R. So these all are then parallel, this is all are parallel, then they are in series. So how to find? Now in this case, the total resistance R equal to, now this is now R by 3, this is R by 3, this is also R by 3, then they are being in series, then we have to add them. So this will give you R equal to 2R upon 3. This is the total resistance in this first case when all bulbs are glowing. So now here we will have the power P1 equal to E square upon R. So this P1 equal to E square, and in place of R we will write down this 2R upon 3. So this will give you this P1 equal to 3 E square upon 2R. And now in second case, this is what in the first case. This is in first case. Now in second case what? We will have 2 from this section A and 1 from section B. So for that we will have the connection like this. This is R, this is R, and this is R. This is A and this is now section B. Now in this case, this is now second part. 2 bulbs from section A and 1 bulb from section B. So here we will have the total resistance R equal to R by 2 plus R. So this is equal to 3R upon 2. So now power P2 is equal to E square upon R, or this P2 equal to E square upon 2R. You write down to this 3R upon 2. So it will give you P2 equal to 2 E square upon 3R. Now you have to find the P1 upon P2. P1 is your 3 E square upon 2R. This is now P1, and P2 is 2 E square upon 3R. This is now P2. So what will you have? P1 upon P2 is equal to 3E square upon 2R into 3R upon 2E square. Now E square will cancel, R will cancel from here. So this is equal to 9 by 4. It means this is your 9 ratio 4. This is the answer. So if you see the option, then here this is coming second. So this is what the solution of this question. So never do it in the air, you do it in fact way, that first you find the power consumption when all the bulbs are glowing, and second when the 2 bulbs from section A and 1 bulb from section B, and then find the total resistance, and then the power P2, and then find the ratio P1 upon P2. So only you have to understand that we are given the 3 resistances here which are in parallel, and 3 resistances are here which are in parallel. So this is the section A and this is the section B. So this is the question number 24. Now I take question number 25. Question number 25. At a point A, on the Earth's surface, the angle of dip delta equal to plus 25 degree. At a point B, on Earth's surface, the angle of dip delta equal to minus 25 degree. We can interpret that interpret that. Now first interpretation. First is what? A and B both are in northern hemisphere. A and B both are in northern hemisphere. A is located in southern hemisphere. A is located in southern hemisphere and B in northern hemisphere. Northern hemisphere. Now option third. Option third is A is located in northern hemisphere. A is located in northern hemisphere. Is located in northern hemisphere and B is located in southern hemisphere. And now option fourth. A and B both are in southern hemisphere. Southern hemisphere. Now the solution. Here the question is given for the angle of dip. First it's plus 25 degree, then minus 25 degree. So we know that the angle of dip is the angle that the magnetic needle makes with the horizontal or the equator of the earth. This is the earth. This is your north, this is south, this is east, and this is west. Now we have a magnetic needle, and the direction is taken from, this is the northern hemisphere, this is now southern hemisphere, and here the north pole of the magnet is always towards downward. This is in this way. And here the magnetic north pole is like this. So this is downward, this is upward. It means that here the angle of dip will be taken to be positive. So on this hemisphere, this is delta is equal to positive. And here delta equal to negative. This is taken like this. in the clockwise sense. So this positive value means the point is lying in the northern hemisphere, and negative means the point is lying in the southern hemisphere. This is the northern hemisphere. Northern hemisphere. This is southern hemisphere. So this is taken according to this, whether the north pole of the magnet is vertically downward or vertically upward. If it is vertically downward, then this is taken to be positive. If it is vertical upward, then this is taken to be negative. So now we see the which question, which is more better. A lies in northern hemisphere and B lies in southern hemisphere. So the third option is the right answer to this question. This is now third question. And now question number 26. A force F equal to 20 plus 10y acts on a particle. Acts on a particle in bidirection. In bidirection. F is in Newton. F is in Newton and by in meter. Work done by this force, you have to find work done by this force. Work done by this force to move the particle from y equal to 0 to 0 to y equal to 1. Meter y equal to 1 meter is now your options. First option is 30 joule. Second option is 5 joule. Third option is 25 joule. And fourth option is 20 joule. These are the options. Now solution. Now you are given the value of y from 0 to 1 meter. Force is also given. So work done, W is equal to integration. Now we have the formula by1 to by2 f dy. So now this is given your, here is by1 equal to 0 and by2 equal to 1 meter. So 0 to 1. F is given 20 plus 10y into displacement dy. So this will be what? Work done. This is now your 20y plus 10y square upon 2. We just integrate and now we put the limit 0 to 1. So now for 0 this will be 0. This is now 20 into 1 plus 1 by 2 into 10 into y is equal to 1. This is now 1 square. This is for limit 1 and for 0 this will come out to be 0. 20 into 0 plus 1 by 2 into 10 into 0. This is what? So this you can see, this is now 20 plus, this will cancel by 5. So this is now 5. This all will be equal to 0. So this is now 25. So much. So much work will be done by this force. So now the right option is come third, 25. So our answer is third one. So whenever we are given the force in terms of the displacement, and displacement is given from so and so to so, then you find to just by method of integration. If suppose limits y is not given, then just you find the dot product f dot dy. That will give you the answer. And now question number 27. Pick the wrong answer. Pick the wrong answer. In context with rainbow. With rain. Now first option is the order when light ray undergoes light ray rays undergo two internal reflections. Internal reflections in water drop. Second, the order of color is reversed. The order of colors is reversed in secondary rainbow. In secondary rainbow. Secondary. And now option third. Option third. In option third, an observer can see a rainbow and observer can see a rainbow Rainbow when his front is towards sun. When his front is towards sun. And now fourth option. Fourth option, rainbow is combined effect. Rainbow is combined effect. Combined effect of dispersion refraction and reflection of sunlight. Now here all is given about the secondary rainbow, and we know that in secondary rainbow two internal reflections takes place inside the drop, and also the color, the order of colors is reversed in secondary rainbow in comparison to primary rainbow. So this is also right, and observer can see the rainbow when his front is towards the sun, and we know that rainbow is always formed in the opposite direction of the sun. So just to see it, our front must be towards the rainbow. It means that the third option is wrong, and rainbow is the combined effect of dispersion, reflection. This is also right. Dispersion takes place, reflection takes place, and dispersion also takes place. So this is what in case of secondary rainbow. So our right choice is the third question, third option. So our answer is third. So this is what the questions that I have to tell you today, and you all like, share and subscribe this video, and also you read it carefully. Thank you very much.